Last week we covered the power rule, and I left you with the challenge problem. Calculate the derivative at x equals 2 of x plus 2 all of this squared. This shall be our starting point for today. As we learned in our last video, you can use the power rule to calculate the derivative of this function. You can approach this in two ways. Either expand the function first, then evaluate the chain rule, or evaluate the chain rule first, then simplify. So let's do option 1. So by expanding our original function, we get x squared plus 2x plus 4. Now using the power rule, we get the derivative of f of x, which is f prime of x, is equal to 2x plus 4. Now that we have our derivative function, we can substitute 2 into our function and get that the derivative of x plus 2 all of this squared at x equals 2 is 2 times 2 plus 4, which is 8. Now doing option 2, let's try and evaluate the power rule without expanding our function. Using the power rule first, we get that the derivative function is equal to 2 times x plus 2 to the power of 2 minus 1. And after expanding this function, we get that f prime of x is equal to 2x plus 4. So now you can see that both methods work, but why do they work, and is any one better? This is the topic of today's video, the chain rule, an application of the power rule. So let's revisit an old mathematical concept called composite functions. A composite function is generally represented by fog, and no, not the mist fog, it's f of g of x. Composite functions, as the name entails, is when you substitute a function into another function, and it's best described with an example. So let's return to our original problem and define a function h of x, which is equal to x plus 2 all of this squared. We can define two functions that make h of x, being f of x, which is x squared, and g of x, which is x plus 2. By using fog, or f of g of x, we take the g of x function and substitute this function into the x terms of f of x. And this gives us h of x is equal to x plus 2 all of this squared. So now that you can see that h of x is really composed of two functions, f of x and g of x, it makes sense to take the derivative of the first function, then multiply it by the derivative of the second function. And this, my friends, is the chain rule. So let's put it into practice. Let's find the derivative of h of x, so h prime of x, which is the derivative of f prime of g of x times g prime of x. Or in other words, taking the derivative of the outer function f of x, then taking the derivative of the inner function g of x. This is pretty intuitive, so let's evaluate this. H of x is equal to x plus 2 all of this squared. So h prime of x is the derivative of the outer function, which is 2 times x plus 2 to the power of 2 minus 1, times the derivative of the inner function, which is 1x to the power of 1 minus 1 plus 0, which is just 1. So we end up with 2 times x plus 2 times 1, which is just 2x plus 4, which is the same answer that we got earlier in this video. So formally, the chain rule states that the derivative of f of g of x is equal to the derivative f prime of x g of x times g prime of x. Or, in other words, take the derivative of the outer function, then multiply it by the derivative of the inner function. Let's try some more difficult sample problems to really solidify our understanding of the chain rule. Let's define a new function, q of x is equal to 2x cubed plus 5x, all of this to the power of 3. The question is to calculate the derivative of this function at x equals 2. So let's remember that the chain rule states that the derivative of f of g of x is equal to f prime of g of x times g prime of x. So we can split q of x into two components, f of x, which is going to be equal to x cubed, and g of x, which is equal to 2x cubed plus 5x. Now that we have defined our two components, the derivative of q of x is equal to q prime of x, and this is the derivative of f prime of g of x, which is 3 times 2x cubed plus 5x all to the power of 3 minus 1 times the derivative of g of x, which is 2 times 3 times x to the power of 3 minus 1 plus 5 times 1 times x to the power of 1 minus 1. And after simplification, we get that q prime of x is equal to 3 times 2x cubed plus 5x to the power of 2 times 6x squared plus 5. Now we substitute 2 into our function and we get the derivative of q prime at 2 is equal to 58812. So in summary, the chain rule is just an application of the power rule for composite functions. You can 100% expand the function and do the power rule normally, but the chain rule simplifies this process for larger power composite functions. In conclusion, you can use the chain rule to calculate the derivative of any composite function, and all you need to remember is take the derivative of the outer function and multiply by the derivative of the inner function. And with that, stay tuned for more calculus and keep learning.